Oh, oh. Okay, sorry students. So once again I explain this one. Student, how many positive integers n can be formed using the digits 3, 4, 4, 5, 5, 6, 7 if we want n to exceed 50 lakhs. Okay. So how many digits are there? Total 7 digits are there. Okay. So n want to be exceed 50 lakhs. Okay. So this first digit should be greater than or equal to 5. Okay. That means x. So n is represented by x1, x2 up to x7. Okay. So this x1 should be either 5, okay, or 6 or 7. Then only it exceeds the 50 lakhs. Okay. So first I am going to place here the digit 5. Okay, 1 5 I have placed. I have fixed the first 5 here. Okay. So how many different possible digits we get? So remaining are 6 no? So 6 factorial by, okay, 4 is repeated 2 times. So 2 factorial and remaining elements are repeated only 1 time. So we got 360. Okay. Okay, students. So next, if x1 is 6, okay, we have fixed this 6 in the first position. Okay, so remaining x2 to x6 can be, so any of these numbers. Okay, so how many are there? 6 numbers are there. So 6 factorial and 4 is repeating 2 times. So 2 factorial and 5 is also repeating 2 times and 2 factorial. Okay, 3 one time and 7 one time. So finally this gives 180. Okay, so this is 360. So if say if if x1 is 7, okay, if you fix the x1 with the digit 7, okay, so the remaining will be, so remaining are 6 letters are not 6 digits, so 6 factorial. Okay, so 1 factorial, so here 1 factorial and 2 fours, 2 factorial, 2 fives, 2 factorial and 1 6, so 1 factorial. So totally we get 360 plus 180 plus 180, so 720. Student, do you have any doubt? So students, we got the sum rule. The number of ends of the desired type is 360 plus 180 plus 180. So 720 we got. Okay. So now, in how many ways can n persons be seated at a round table if arrangements are considered the same question? Okay. See how many ways n can be seated at a round table. See, this is a so the first person can be sit at any place. Okay, n minus 1 places. Okay, remaining n minus 1 persons. Okay, can be seated in n minus. Okay, so anywhere, then the remaining n minus 1 persons can be seated. Total number of ways of arranging the n persons in a circle. Okay, so for example, 9 person has to be placed in a round table. So then the how many are make 9 minus 1 factorial. That means 8 factorial different arrangements we can make. Okay. Okay, students, required to seat 5 men and 4 women in a row so that so student, it is required to seat 5 men and 4 women in a row. Women occupy the even places. How many such arrangements are possible? See, so first, say for example, the man, okay, see followed by the woman, okay, next man, followed by woman, next man, followed by woman, men. So how many men? One, two, three, 4 men, a woman, and followed by men. Okay, students. So this is the position 1 odd. This is position 3. Okay, this is position 5. Okay, this is position 7. Okay, this is position 9. Okay, so 2, 4, and 8. Okay, the men may be seated in odd places. Okay, so these are the odd places now, 1, 3, 5, 7, 9. Okay, so which man has to be sit in the first place and which man has to be sit in the third place? Okay, so we can arrange them internally in 5 factorial ways. Okay, 5 factorial ways. Okay, so in the same way, the woman has to be sit in the second place, fourth place, sixth place, and eighth place. Okay, which woman has to be sit in the second place and which woman has to be sit in the fourth place? So internally, we can make 4 factorial different arrangements. So 5 factorial into 4 factorial, that equal to 120 into 24. So that equal to 2880. Student, have understood? Do you have any doubt regarding this? So it is required to seat 5 men and 4 women in a row. Okay, in a row or in a line. How many such arrangements are possible? So, so second position, fourth, sixth, and eighth, and the men can take 1, 3, 5, 7, 9. Okay, among them they can arrange in internally 5 factorial ways the men and 4 factorial different ways the woman. So there are 5 factorial into 4 factorial, that is equal to 120 into 24. So that is 2880 different arrangements we get. Okay. Okay, student, next one. See, how many ways can 6 men and 6 women be seated in a row? Okay. How many ways? In how many ways 6 men and 6 women be seated in a row? So, for example, so man, woman, okay, man, woman, man, woman, okay, man, woman, man, and woman. Okay, see, if any person may sit next to any other. Okay, so if any person may sit to any other means, so how many men are there? 6 men are there. And how many women are there? Okay, 6 women are there. So for 12, so 12 people can sit. Okay, this is the answer for the first one. Okay, so second one, if men and women must occupy alternative seats. Okay, men and women must occupy alternative seats. Okay, So men and women are must occupy alternate seat means, see, the first man will sit, okay, so followed by woman, so men, woman, and so on. Okay, so this is man can again internally we can arrange them in 6 factorial ways. Okay, women internally they can arrange in 6 factorial different ways. Okay, so this is 6 factorial followed by 6 factorial. So this is, so if men and women must occupy alternative seats. So here first the in the odd position we have arranged the men. Okay, but alternatively we can arrange the women in the odd position and men in the even position. So first can be women. So next can be men, women, woman, man, woman, man. Okay, so under alternative, so women can be internally arranged. Okay, so in the first one, so men occupy the odd places. In the second one, women occupy the odd places. Okay, if the men occupy the odd places, 6 factorial into 6 factorial, different arrangements you can make. If the women occupy the odd places, also you can arrange 6 factorial into 6 factorial. So that is 6 factorial into 6 factorial equal to 5,18,400. Okay, plus 5,18,400 totally. This is 10,36,800 different ways you can arrange if men and women must occupy alternative seats. If men and women must occupy alternative seats. Student, do you have any doubts regarding this? Please respond in the chat box. Hello, students. Any person may sit next to any other. Okay, 45 and 46. Thank you. So we move to the next one. Student, are you able to see the screen? Okay, students. So 4 different math books. Okay, students. So 4 different math books, 5 different computer science books, and 2 different control theory books are to be arranged in a shelf. Okay. So math books. How many math books are there? 4 different math books. See. So 1, 2. So total 4 books are there. Okay. So these are 4 math books. 5 different computer science books. One, two, three, 4, and 5. These are 5 computer science books. Okay, students. Next, 2 different control theory books. 2 different control theory books. These are 2 different control theory books. Okay, or to be arranged in a shelf. How many different arrangements are possible? Okay, the first one. The books in each particular subject must be all together. Okay, so 4 different math books. These are 4 different math books. So all these math books must be together. Okay, so these math books must be together. Okay, and 5 computer science books. All these 5 computer science must be together. And 2 control theory books must be together. Okay, so totally this is how many? 1, 2, 3. 3 groups are there. Okay, so 3 groups can be in 3 factorial ways. You can arrange them. Okay, next, in the first group, how many books are there? 4 books are there. Okay, so 4 math books. So which book has to be placed in the first? Which book has to be placed in the second? That means how many arrangements you can make internally in the math books? Okay, 4 factorial ways you can make. Okay, so 4 factorial ways. Okay, next, 5 computer science books can be arranged internally 5 different ways. Now 5 factorial ways you can arrange them. Next, control theory books. 2 control theory books in 2 factorial ways into 3. Okay, there are 3 different groups are there: math books, computer science books, and control theory books. These 3 can be, so whether first control theory book has to be placed or computer science book has to be placed. So internally these 3 can be arranged in 3 factorial ways. Okay, so math books internally 4 factorial, computer science books internally 5 factorial, and control theory books internally 2 factorial. See here, 4 factorial into 5 factorial into 2 factorial into 3 factorial. 4 factorial, 4 math books. 5 factorial, 5 computer science books. 2 factorial, control theory books. So 3 factorial means, so this is one group, this is another group. These 3 groups can be arranged in 3 different ways. Okay. Do you have any doubt regarding this? Okay. Next, students. B. Only the math books must be together. Okay. Only the math books must be together. Okay, students. So we have grouped all the four math books as a single set. Okay. So next, five computer science books are there na. So we are arranging. So computer science books, one, two, three, four, and five. These are five computer science books. And so next one is control theory books. How many control theory books? Two control theory books. So control theory books, one and two. These are control theory books. Okay. See now how many groups are there? So the entire set is one group. One. Okay. These are individual books, individual groups. Okay. So one, two, three, four, five, six, seven, and this entire set is one eight. So 8 factorial. So 8 factorial. 8 factorial. And internally these can be arranged. Internally these can be arranged in 4 factorial ways. So 4 factorial. So 8 factorial into 4 factorial, that is equal to this much. Student, do you have any doubt? Please respond in the chat box. Student, do you have any doubt? Okay, right. Thank you. We go for next one. Okay, students. So find the number of positive integers that can be formed from the digits 1, 2, 3, 4 if no digit is repeated in any one integer. Okay. See this one. Find the total number of positive integers that can be formed from the digits 1, 2, 3, 4 if no digit is repeated in any one integer. Okay, say total number of positive integers. Okay, so that, so how many digits are there? Four digits are there now. So we can get, so one digit numbers. See, one digit numbers and two digit numbers. Okay, and three digit numbers and four digit numbers. Okay, so no digit is repeated any in any one integer. Okay, one digit number. How many one digit numbers we can get? So one, two, three, and four. Okay, so that means four different one digit numbers we get. Four different one digit numbers we get. Okay, how many two digit number we get? Say first digit can be filled in how many ways? Okay, four digits are there now. So first can be either one, two, three, four. Okay, that means this can be filled in four ways. Okay, so for example, the first one is filled with any one of the digit. How many digits are remained for the second position for this one? So only three digits are remain. Okay, so 3 into 4, that means, so 12 ways, 12 different digits we get of two digit numbers. Okay, so three digit number. In the three digit number, see, the first one, how many choices are there? Either one, two, three, four. That means four choices are there. So four ways we can fill the first one. For the second one, we already filled the first place with one of these. So available digits are only three. So this can be filled with three digits. Okay, next, this can be filled with only two digits are available to fill this position. So two ways we can fill. So 2 into 2, 3 into 4. Okay, so that equal to 24 different digits we get. Three digit numbers we get. Okay, so next four digit numbers. So this can be filled with four ways. This can be filled with three ways. And this can be filled with two ways, and finally this can be filled with one way. So this is also 1 into 2 into 3 into 4, that equal to, so 24 we get. Okay, so the total number of positive digits, one digit numbers, how many get? Four one digit numbers we get. Two digit numbers, 12 two different two digit numbers, and 24 different three digit numbers, and 24 different four digit numbers. The totally 4 plus 12 plus 24 plus 24. Okay, so that equal to 64. Okay, students, do you have any doubt regarding this? Please respond in the chat box. This is if no digit is repeated. Okay, if no digit is repeated in any one integer. Say for example, if the digits can be repeated, if the digits can be repeated, then see, the first one digit number, it can be, so four ways you can fill. So four, okay, two digit numbers. If the repetitions are allowed, this can be filled with four ways, four possible digits, and this is also in four possible digits, 4 into 4. So this is 16 ways you can fill, or you can also write it as 4 square. Okay, three digit numbers. If the repetitions are allowed, okay, this can be in 4 ways. So for this also 4 digits are available for the second position, and for the third position also 4 digits are available. So that means, so 4 cube. Okay. So next for the 4 digit numbers, 1, 2, 3, and 4. This can be in 4 ways. Okay. So this is also 4 ways. Okay, this is also 4 ways. So because the repetitions are allowed now, so even 4 is 1 digit is filled with one position. All the digits are available for the second position also. So this is 4 power 4. So 4 plus 4 square plus 4 cube plus 4 power 4. Okay, that many 4 different number of positive integers are possible if the digits are repeated. Okay, so if the digits are not repeated, this one. If the digits are repeated, this one. Student, do you have any doubt regarding this? Please respond in the chat box. Hello, students. In this, okay. Students, to find the value of n, so that, okay, 2 into p of n, okay. So permutations of p of n comma r. we already know that P of n comma r, P of n comma r for minus r factor. Okay, the meaning of this is from the given n objects, okay, we have to choose all objects and arrange them in the order. Okay, that is the meaning of the permutation. What is the meaning of permutation? P n minus r factor. That means from n given objects, you have to select the all objects and arrange them in the particular order. Okay, so find the value of n so that 2 into p of n comma 2 plus 50 equal to p of n 2n comma 2. Okay, simply write the formula. Okay, so 2 into n factorial p of n comma 2 equal to n factorial by n minus r. That means n minus 2 factorial plus 50 equal to p of 2n comma 2. That means instead of n they given 2n. Okay, 2n factorial by 2n minus 2 factorial. Okay, after simplification, see here, so it becomes 2 into n factorial becomes 2n factorial. Okay, so by simplification we get 2n into n minus 1 plus 50. Okay, by expanding this and simplify this we get equal to 2n into 2n minus 1. Okay, see what is, see, so 2n factorial by 2n minus 1 factorial means 2n into 2n minus 1 into 2n minus 2 and so on. Okay, so the remaining will get n minus 1. Okay, after simplification we get n square equal to 25. Okay, that means n equal to plus or minus 5. Okay, n should not be negative now. So here, so n equal to 5. N equal to 5 we get after simplification this. Okay, students. Student, do you have any class after this one? Student, if you have any other class after this, okay, after this if you have one more class, okay, that means afternoon from 1 to, sorry, 3, sorry, 2 to 3. Okay, students. So because tomorrow I may not be available, so for tomorrow's class also I'm going to take today itself. Okay, students. So you will have one extra class today from 2 to 3. So even afternoon also we have a class. See, do you have any class after this class? That means from 12 to 1. I don't think you have the class from 12 to 1. If that is the case, I'm going to take the class from 12 to 1. Okay, students. Okay, students, thank you. Have a nice day. So you will have the class from 12 to 1. Okay. So after 12:55 you had class. Okay, students. Anyway, today I'm going to take one more class. Okay. So I will schedule and I will inform you. Okay. Okay. Thank you.